Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It's Jaron from Jeranism, back with a short video for you. A video where I will be showing you a recent article that allows me to feel, in a way, kind of vindicated. A while ago, when talking about planes traveling in the southern hemisphere, I stated that those passenger planes could be traveling faster than the speed of sound and actually be traveling much greater distances without anyone knowing. My reason for this was, of course, the jet streams. And what happened? Well, when I said it, I was laughed at and told it wasn't possible for passenger planes to travel faster than the speed of sound, even though I showed them that the jet stream in the south was often 200 plus miles per hour, but to no avail. Well, let's take a look at this article. It's from February 19th, 2019 on the website theweek.com, and let's read it. First, in its entirety, it's titled, "The jet stream is moving so fast right now that commercial planes are traveling faster than the speed of sound. If you're flying east today, you're in a whole lot of luck. The jet stream, that funny little channel of high-altitude air that flows over the United States and northern Atlantic, is moving at unheard-of speeds, delivering commercial jets to their destinations nearly an hour ahead of schedule," the Washington Post reports. In fact, one Virgin Atlantic flight traveling from Los Angeles to London notched a speed of 801 miles per hour over Pennsylvania, which, had it been on the ground, would have been faster than the speed of sound. Thankfully for passengers on board, the plane itself didn't actually break the speed of sound because, as the Post puts it, it was embedded in the swiftly moving air, so only its horizontal speed over land or ground speed crossed the 767 mile per hour speed of sound threshold. The plane's true airspeed, or speed at which the air was passing over the wings, would have been much lower. Still, the speed is impressive, and it is thought to be a record for a Boeing 787-9 Dreamliner, which has a usual cruising speed of 561 miles per hour. Other flights have also been catching an extra boost from the high winds. A 737 traveling from Chicago to New York hit a ground speed of 700 miles per hour on Tuesday morning, with that route's estimated travel time down to 1 hour and 24 minutes from the usual 2 hours. If you're flying west, alas, the jet stream won't be quite as fun. The Post expects westward flights out of New York and New England to see up to an extra 30 minutes of travel time. All right, so let's go through it and pull out a few important parts. First, you have to be traveling east, which is the same way that the Earth spins. So remember, you're spinning 1,000 miles per hour, and so the atmosphere, which is attached to the Earth, and the winds are all moving 250 miles per hour or faster. And why do I say faster? Hold that thought. But remember that these winds are blowing faster than even the spin of the Earth in the same direction. So take a basketball, have an attached atmosphere, spin it, and then try to make the winds go faster than the spinning basketball in the same direction. Ridiculous. It then mentions the jet stream as a channel that exists over the United States and northern Atlantic, and this is a little bit confusing as it also exists elsewhere and is the quickest the further north or south you go, because winds are because of temperature, and the largest difference between hot and cold temperatures would exist closer to the north and the south. You'll also see here that it mentions a ground speed of 801 miles per hour, and then lastly it tells us that the plane didn't actually break the speed of sound because it's being carried by the high velocity winds, which is exactly what I have been saying. Now, notice there's no mention of the actual speed of the jet streams, probably because they'd rather you did not know, but I typed in southern jet stream speed, and you'll see that the greater the difference in the air temperature, the faster the jet stream, which again tells us that the polar jet streams would be the fastest, as the greatest temperature differences exist there. Also note that it says that the jet streams can reach speeds up to 250 miles per hour or greater. That's just funny. Up to 250 miles per hour or greater? Okay, well, my feeble mind says that up to 250 miles per hour then is an incorrect statement if they can also be greater. You know, my car can hold up to 5 people or greater. Well, which is it? Well, these little tricks are important and for a reason. So now I've pulled up the earth.nullschool.net, and if you haven't seen the video that I released earlier today, I think you can just click up here somewhere if I did this right, and you can watch a video about how earth.nullschool.net removed the very useful AE projection. So unfortunately, I can't show you the jet stream winds on the AE projection. We're going to have to look at them on a globe. So the first thing you'll notice is that they predominantly move east, but I've seen slower winds move west at higher and lower altitudes. You'll see here that we're looking at a height of about 30 to 35,000 feet. So you can see here that up past the northern part of the United States and out over the North Atlantic, the winds are moving 100, 150, and even 243 miles per hour. Those same winds in the south are moving just as fast. Now, unfortunately, we can only see the wind speeds at altitudes of about 30,000 feet because on earth.nullschool.net, the settings only allow 1000 HPA, 850, 700, 500, and 250. Well, at 70 hectopascals, we can see decreased speeds to 50 miles per hour, some moving west and not east. But 70 hectopascals is at a much too high altitude for airlines because here you can see, and I typed in 250 HPA to see that it says 250 is about 35,000 feet. And if we type in 70 HPA, we can go to the Controlled Opposition conspiracy debunking site of the filthy rich video game designer and traitor to humanity, Muck West, who gives us a chart showing different HPAs and how they correspond to altitude. Now, unfortunately, 500 HPA is below 20,000 feet. That doesn't help us much for commercial jets, and 70 HPA isn't even listed, as it would probably be well above 60,000 feet. So between 20,000 and 60,000 feet, Earth.Null gives us only that one option, which is 30,000 feet or thereabout. So as you can see, the only way we can check out the winds is at 30,000 feet, not at 35, not at 40, not at 45,000, or even 28 or 25,000. So at 33,000 feet, we can see that this massive 200 mile per hour plus jet streams that planes most certainly use, in fact, they can be predicted, and flight paths are drawn up with these winds and channels in mind so that planes can use them. And you'll see that they exist both north and south. Now, you can also see that the channels themselves stay consistent. Maybe not day to day, but they can stay consistent enough for plane and flight paths to heavily use them. Again, what speeds are at 30,000 feet or 35,000 feet or even 38,000 feet or 40,000 feet or 42,000 feet, heights that we know that these planes can possibly be flying? Well, we don't know. Perhaps they're even greater. And again, remember that they go east, the direction that the Earth spins, and that's just insane if you actually believe that you're on a spinning space rock flying through outer space with this predictable gas atmosphere attached to the Earth as it spins next to a vacuum. All right, here you see I've brought up Flight Radar 24, which is a site where you can track flights, and I've just typed in Sydney to Santiago. And if we zoom in here, you can see what happens, and the problem that we have with these flights is that as soon as they take off from Sydney, gets out over the open water and, of course, drops off and just skips to that next location. And then it will fly over New Zealand there. And again, once it gets to a certain spot, it just disappears from radar until it appears all the way on the other side over here by Santiago, Chile. So again, you can see that this plane got up to almost 680. I think I saw 684 miles per hour ground speed, and then it disappears. So we have no idea how fast this plane could be possibly traveling once it gets up high enough to be in those jet streams and traveling across the Southern Ocean. And you can go to any of these flights. It's not just one. I didn't pick this one particularly. Let's scroll down here and find another one, just a random one. We'll just choose this one here. Who knows? And this flight nearly took 12 hours. And again, it's going to be the same thing every time. You start to drag this little thing. The plane leaves Sydney, gets out over the open ocean, and again, skips till it gets to New Zealand. Then it will fly over New Zealand for a little bit, and then again drops off the radar, and you'll see here, that plane will simply get up to about 600, in this case, heading north of 600 and something miles per hour, and then you don't see it till it hits the other side. So we have no idea what's happening in this downtime where the satellites can't pick up, I guess, the speeds of this plane. Craziness. Another thing you'll notice is that that plane there flew right over the southern tip of New Zealand. You can see that, right? The little purple line. So let's scroll down a little bit further and see if we can find a flight that does not. Usually it'll be these ones down here like this one. It doesn't have a time, and the reason why is because it takes off, and you'll see here it went well south of New Zealand. See that line? Didn't even fly over New Zealand. Why? Well, because as I just showed you, the planes adjust their flight as per the jet streams. That's how they fly. So we don't know, again, let's look at this one. We don't know from the time it left, for how many miles is that off the coast? 100 miles? I don't even know. But not very far off the coast, and we get it to completely disappear. So, again, we have no idea what's going on out there over the Southern Ocean, and, those planes could be traveling much, much faster than we're told. Let's look at another one here just to see what this one does. This one flies over the middle of New Zealand. See that? We started going. Here comes the plane. It takes off. You see its ground speed approaching. Look at that. It got up to high 600s. What did we get? 650 something. Flies over New Zealand. at 650 about, and then disappears till it gets to the other side, all the way over by South America. So again, what if this plane was actually flying over that huge stretch that we can't see, some 6,000 plus miles according to the globe? What if it was traveling much, much faster as it got up in these jet streams? Well, let's look at an example. And so this is just a little quick example that I made here. Let's say we've got a plane going Sydney to Santiago, as we just showed. That travels 7,000 miles in 12 hours, which is about the average flight time. 7,000 divided by 12 equals 583 miles per hour. All right, but what about the jet stream? So remember, it's helping the plane with close to 250 mile per hour winds. So if the plane is being helped, well, 583 miles per hour minus 250, is the plane actually going 333 miles per hour? And then it's getting the extra 250 to end up at 583? Well, that doesn't sound very efficient, does it? So let's look at it this way. What if that plane was actually going 625 miles per hour, which we saw, ground speed. We also know that that's easily under the speed of sound. 625 miles per hour plus 250 miles per hour, which would be the most efficient thing, is 875 miles per hour ground speed. Okay, so a plane from Sydney to Santiago could be going 875 miles per hour for 12 hours. 875 times 12 is 10,500 miles instead of 7,000 miles. I mean, quite a difference, right? And again, this plane, this example I'm giving here, could be going 875 miles per hour, and it wouldn't even be breaking the speed of sound. Now again, I have to say it because people will forget it, that I'm not saying how far that plane actually travels or at what speed, because as I've just shown you, we don't know the exact speed of these winds at altitude, but they do. We just know what we're told. So please remember, I'm not trying to make any new claims here. As I've claimed in the past, the planes can go faster than the speed of sound. We've just seen that now in the article. And speeds of the jet streams are the greatest the further north or south you go because of the temperature differential, which I've mentioned before. The people making claims are the ones saying that flight distances in the south prove a globe. Well, guys, you simply do not know the distances planes travel or the speed unless you take the globe as a fact. If it's possible we don't live on a globe, then it's very possible planes travel further and faster than you've been told because we don't know the true layout of the southern vast oceans, nor do we know for facts the speed of sound at altitude, nor do we know the speed of the jet streams, or what exactly the planes are doing during that long 12-hour trip. Remember, the plane going back still takes 15 plus hours, but it too can be using the jet streams that go west at different altitudes. Again, we can't see the winds that are higher or lower than 33,000 feet, so it's hard to say. But the truth is, engines today are more efficient at higher altitudes and higher speeds, and I wouldn't doubt it, they're simply going faster than we've been told. And as I always say, it's up to you to decide. You can choose. If you don't think that we've ever been lied to, then good for you. I'm smarter than that, and now you see why anyone who says Southern flights prove the globe are either too scared to consider the alternative or just haven't researched enough. But now you know planes can and do fly faster than the speed of sound, and who knows how far or fast they are actually going. All right, and if you want to support my channel, you can go to my PayPal or my Patreon. Those links are in the description. My Venmo is on the screen, or you can support me for free by liking or sharing this video, which I would greatly appreciate. Or if you shop at Amazon, just go to Jeranism.com first, hover over support in the upper right, and then click Amazon, and you'll go right there and pay what you always pay. Plus, I get a little small percentage. Or you can type in j.mp/JeranAMZ into any web browser, and that too will take you to Amazon, where you can shop like you normally do. Up next, we have some animals that are fans of mine that are going to dance us out of here, and I remind you to do your own research, because when you do, you'll never again believe what you've been taught. Till next time, this has been Jeranism.